Good day everyone. Today we are going to discuss about the number systems in the computer. First, let us see about the data representations. So the data are stored in the computer in many different formats. So we'll be using numeric data, alphabetic data and alphanumeric data. So what is numeric data is you will be using the symbol from 0 to 9, and for alphabetical data you will be using from the character A to Z. So what will be alphanumeric data is it's a combination of symbols like A to Z, 0 to 1 and special characters like plus, minus, blank symbol and etc. All the data are stored in the computer in the format of binary system. So what is the format you will be using here is all the data will be represented in terms of zeros and ones. So each symbol is represented as a unique combinations of zeros and ones. So if it is going to be A will be represented in terms of some combinations of zeros and ones. So what are the commonly used number system in computers? So we'll be using binary binary system to octal, hexadecimal and decimal system. So these are the four commonly used number systems we are using in computers. So let us see what is the number system in computers. So what is the number system is each number system will be represented based on the base called or. Okay, so we call it as base or radix. So the numbers will be represented to the base of some value. Here each number will be having three values. One is face value, another one is a position value and another one is a uh, base. For example, if you are using a decimal value, right about like 86 or something like that. So if it is 86, so this we write it in the form of decimal format. So that means it's a decimal number. So what is the face value is, so we will be calculating the positions. So the positions will be calculated from left to right. So the position of 6 is 0 and the position of 8 is 1. So this is the position value. And what is the face value is, so you will write the face value like 8. So your face value will be 8 and 6 and your position value is 0 and 1. So how do we calculate the number of the decimal number is, so you can see here it will be calculated in the terms of face value into the base of position. So what happens is it will be represented as 6 into 10 power 0 plus 8 into 10 power 1. So which will be equal to 80 plus 6, which is the value 86. So this is how a number is calculated in the number system. So how a number is represented in the computers, it will be represented using face value, position and base of the system. So let us see what are the commonly used number systems in the computer. So we'll be using decimal number system, which is of base 10, and you will be using binary number system. From the name binary itself, it is using only two symbols, so it is will be of base 2. And octal number system is of base 8, so it will be using 8 symbols for representing any number. And the last number system is hexadecimal number system. It uses 16 symbols to represent a number. Let us see the first decimal number system. So the first number system is going to be decimal number system. It consists of 10 digits, that is 10 symbols from 0 to 9. It will be using from 0 to 9. It is used to represent any number. So any number will be represented with the combination of this 10 digits, that is from 0 to 9. Example 45, 856, 58, 8461. So the position value and face value for the number system is represented as in this fashion. You can see here the integer part, the position value will be calculated from left to right. So it will be calculated from left to right. It is 0, 1, 2, 3. Similarly, the fractional parts, it will be calculated. The position values will be calculated from right to left. You can see -1, -2, -3. So the based on the position value, what will be the base value will be calculated is, it will be 10 power 3, 10 power 2, 10 power 1, 10 power 0, and this will be of 10 power -1, 10 power -2, 10 power -3. So this is the decimal number system. So we will see the example how it is used. So the next system is a binary number system. As I said before, from the name, the binary number system will be consisting of only two digits, that is 0 and 1. All the numbers will be represented using the combinations of 0 and 1. Example, this is how it will be represented: 1001, 110001. So what will be the position value and the quantity of the number is? So this is what the position value. Similarly, in binary number also, the integer part will be calculated, the position value will be calculated for the integer part from left to right, and the fractional part, it will be calculated from right to left. So you will be having from right to left. So here it is a binary number system. So here my base is 10, base is 2. So you will be having 2 to the power of the position value and 2 to the power of 2, 2 to the power of 1. So this is how it will be calculated in binary system. So the next one is going to be octal binary system. So octal binary system is base 8. So that means it is using 8 digits to represent any number. So the 8 digits are going to be 0 to 7. So all the numbers will be represented with only the combinations of 0 to 7. So you will be having only from 0 to 7 to represent any combinations. So what will be the position value and phase values will be calculated? So this is how it will be calculated. Similarly, so the integer parts will be traveling from left to right. Here it is from left to right, the position values are calculated. And for the fractional part, it will be calculated from right to left. Okay, so this is for the octal number system. Next one is for hexadecimal number system. You will be consisting of 16 digits to represent any number. So it will be having from 0 to 9. Okay, so you will have 10 characters. The remaining characters will be represented as A, B, C, D, E, F. So why is it so? Suppose 7, 8, 9, after 9 it is going to be 10. So 10 is going to be 0, 1, 0. Already 0 and 1 is a symbol in hexadecimal. So we cannot use the value 10 over here. So this we represent as A. Similarly, we have B, C, D, E and F, which represents the number value 1, 11, 12, 13, 14 and 15. Okay, so the examples are going to be like this. So any number will be represented only in this format. Same thing, the integer part will be calculated, the position value will be calculated from left to right, and the position value will be calculated for fractional part from right to left. Let us see the example. So this is the table that consists of decimal value, binary value, octal value and hexadecimal value. So you can see here from 0 to 9, I can use the symbols for hexadecimal 0 to 9. But for 10, it is nothing but a combination of 0 and 1. So what happens is that will be represented as A, B, C, D, E and F. So 16 will be represented as 10. So how it is done? So we'll see an example how we can do that is in the upcoming session, that is conversion from decimal to binary and binary to decimal. So in that way, we can understand how the decimal values are converted into binary and how binary can be converted into octal, how octal can be converted into hexadecimal. So we'll see an example for that. Let us first see the conversion from decimal to other bases. So here we are going to see the conversion from decimal to binary, octal and hexadecimal. So first thing we are going to see is from a decimal is to be converted. So we will be converting a decimal value. So the example we are going to see here is a decimal is going to be converted into binary format. So how do we do it is a decimal number is converted to base 10. So here we are going to see from base 10 to base 2 conversion. Okay, from decimal system to binary system. So how will you do that is you will just divide the decimal integer by 2 and we will record the remainder part alone. So let us see an example. I am going to convert the decimal value 25 to a binary equal. So as I said before, if you want to convert a decimal into binary, you have to divide by 2. So now what I do is I am dividing 2 by So 25 is divided by 2, so 12 is the quotient and the remainder is 1. Similarly, 12 is divided by 6, so the remainder will be 0. So 2 into 6, 12, it is remainder is 0. Next thing is 6, so 2 into 3 will be 6, you will have remainder 0, and 2 into 1 is 2, so remainder will be 1, and 2 to 0 is 1, so you will have a remainder 1. So how the answer will be written is, the answer will be written from the bottom to top. So that is, from bottom to top the answer has to be written. So it is 11001. So 25 to the base of 10 is converted to the binary equivalent 11001 of 2. So that is the answer for thing. So we will have another example. So the next example is converting 23 to the binary equivalent. Same way we will divide L division, we will use the L division and we will divide 23 by 2 consecutively. So 2 into 11, 22, so 23 minus 22 is remainder is 1. 2 into 5 is 10, so 10 minus 11 is 1, so remainder is 1. And 2 into 2, 4, so 5 minus 4 is 1, so remainder is 1. Then 2 into 1 is 1, so 2, it will be remainder is 0. So finally you will have 2 into 0, so the remainder is 0, so you will get 1. So you will write the answer from bottom to top. So it will be 1 0 triple 1 2 is the answer for the given number. So this is how we will convert. So understand, if you want to convert a decimal from base 10 to base 2, just divide the number by 2. So divide the number by 2. So you will be dividing using value 2. So divide by 2. So next thing is how a decimal can be converted into octal. So how a decimal can be converted into octal, that is from base 10 to base 8. That is decimal to octal conversion. So what you are going to do is you will divide by 8. You will be dividing it by 8. So let us see the same example 23. I want to convert decimal 23 to octal equivalent. So what I do is, so I divide 8 by, so 23 will be divided by 8. So if you are not comfortable with this, you can write like this 23. Okay, so 8 2 times 23 will be done, so it is 16, so remainder is 7. So you have to write 2 and 7 together. So this way of writing will be little bit difficult, so I'm writing it as 8 into, so 8 is, this is quotient and this is remainder, so 2 7. Then finally again with 0 I'm doing, so you'll get, so it is going to be 2 7. So 23 is represented as 2 7. So 23 of 10 is giving 2 7 of 8. So let us see in another example 147. Okay, so it is multiplied with 18, so you will get remainder 3. When 8 is multiplied with 2, it's 16, so 18 minus 16 is 2, so remainder is 2. Finally you have 2, so 147 to the base of 10 is converted into 2 2 3 of 8. So this is what the conversion is. The answer has to be written from in this format. Okay, so this is the example for converting decimal number into a octal number. So next we will see how a decimal number is converted into a hexadecimal number. Simple, if you want to convert a decimal into hexadecimal, we will divide it by 16. So we will divide it by 16. So you will divide the decimal number by multiple times. You will divide it by 16. So let us take an example 147. So 147 16. So into 9 you will get remainder 3. Again 5 0 you will get 9. So it is going to be, so 147 terms of sum. So 147 base of 10 is converted into 9 3 of 16. So if you want to convert a decimal to binary, just divide by 2. If you want to convert to octal, just divide by 8. If you want to divide it, convert into a hexadecimal, then divide by 16. So this is conversion of decimal to binary, octal, and hexadecimal. Okay. So this is the example. So next we will try to convert how a fractional. Okay. So now we have used only the integer part. So let us see how fractions can be converted into an binary, octal, and hexadecimal. So the conversion of decimal fraction, that is, what is the decimal fraction is? So here we are going to convert decimal fraction, that is like 0.2345 has to be converted to binary octal. So first we will take 2 base 2. So what I have to do here is I have to just multiply by 2. That's it. You have to multiply by 2. So the fractional numbers, which will be always less than 1. So if it is less than 1, that fractional part must be multiplied by 2 for simple example. So you have to take only convert the integer part alone into your answer. For example, so 0.235, if it is multiplied, it will become 0.4690. So you will take only the number that is in the integer part. So your answer is 0 over here. Then again the same thing is multiplied with 2 here. It is again 0.9380. Here integer part again still it is 0. When 0.9380 is multiplied by 2, it gives 1.8760. Now the integer part is 1. So it is going to be 1 over here. For the next iteration, you take only the fractional part. We should not take the integer part. So take only the fractional part for multiplication. Fractional part for multiplication. Okay, so you have to take it for multiplication. So what happens is 1 is left over, only 8760 is alone taken. When it is multiplied, it gives 1.7520. So the answer is 1. Here again that 7.520 alone is taken for the next iteration into 2. It is goes on 1. Again 0.50, it multiplies is 1. And you can continue as far as much as you need. So now how the answer to be written? In the decimal integer part, top to bottom we have considered here. Sorry, bottom to top we have considered in integer part. Here we are going to consider in this fashion from top to bottom. Okay, so this is first iteration, this is second iteration, this is third iteration, and this one is fourth iteration, this is fifth iteration, and sixth iteration. So now what you will do is you will write the answer. Okay, so 0.2345 to the base of 10 is converted to the binary format. So from first iteration, the integer value is 0, 0, third iteration is 1, fourth iteration is 1, fifth iteration is 1, sixth iteration is 1 to the base of 2. If you want, you can extend still. So this is how the answer is written. I repeat again, take only the fractional part, multiply by 2, and consider only the integer for your answer. So when you have 0, there is no issue. Continue with the same fraction, multiply again and again. When there is more than 0 in integer part, just consider it for the answer and exclude it for the next iteration. Exclude it means avoid, remove the integer part and just take the fractional part alone for the next iteration alone. Okay, you can see here we have considered only 8760 for our iteration. We didn't consider the integer part. So just remove the integer part and consider only the fractional part for multiplication. So let us see in another example so we can understand how clear it is. Now I am going to consider 0.8650, that is decimal part, is to be converted into the binary format. Okay, so I am going to do it for all the three things. I am going to do it for binary, octal, and hexadecimal. So this first term is for binary, and the second one is for octal, and the third one is hexadecimal. Okay, So this is for octal and this is for hexadecimal. Sir, how you understand this? So you can see here it is multiplied by 2 here, and here it is multiplied by 8, and here it is multiplied by 16. Right. First we see for the numbers alone for binary system. So 0.865 it is multiplied, you will get 1.730. So consider 1 alone. So 1 is taken. When the fractional part is multiplied again by 2, you get 1. So it is 1. So you have to consider from top to bottom. So the I will write it over here. So the binary, so the binary system is, so from top to bottom you consider the integer part. It is 1 1 0 1 1 1. So the binary is, you write it as 0.11011. So this is the answer for the fractional point 0.8652 binary system. Now for octal, similar fashion you have to do. So 0.865 will be multiplied by 8, it is 6.920. So 6 alone is considered for my answer. 0.920 alone is taken for next iteration, multiplied by 8, you get 7.360. Consider 7 for my answer. So I will take it as like this. So 0. First value is 6 and 920 is multiplied by 8, we get 7.360. So I will consider only 7. 360 is multiplied again by 8, you get 2. So you will get 2.880. Now 880 is again multiplied by 7, it is going to be 7.047. So you will have 7, and this is of base 8. So do I have to do only 4 times? Yes, you can do it for 5th time, 6th time and 7th time, because point you can extend it to any values. Next thing is we are going to go for hexadecimal. Okay, so hexadecimal to the base of 16, same value. So 0.865 is multiplied by 16. Here it gives 13.840. So 13 is a whole number which should be represented as D. So we will take it as D. Similarly, 0.840 is again multiplied by 16. You will get 13. So which will be converted into D again. So D. Then 0.440 is again multiplied by 16. You will get 7.04. So the integer part is 7. If you want, you can continue the next iteration and you can find the answer. So if you want, you can try it out. So if it is going to be 0.040 into 16, so it will be 0.640. Okay, so the answer is 0. So you can have 0 over here. Right. So you have this. So you understand. Right. So. Okay, so this is how a decimal number is converted into binary, octal and hexadecimal. So let us see how a decimal with the integer and fractional part is converted into binary and octal and hexadecimal. So first we are going to see how integer dot fraction is converted into binary. So what you will do is, integer part will be divided by 2 and the fractional part will be multiplied by 2. Combine these two answers together to get the final answer. For example, the 34.467, so 34 will be divided by 2 and 0.4674 will be multiplied by 2, and both these answers are being combined together. So when you see 34 is divided consecutively by 2, and we'll find what is the remainder. Again, I tell you, here the remainder will be read from bottom to top. Okay, so here it is from bottom to top. Okay, and the fractional part, it is from top to bottom. So bottom is over here. Okay, so it's a iteration, consecutive iteration. So it goes on like this, right? So when you do it for 34, it is going to be 10010 dot, and here it is from top to bottom. So 0111111, so 01101 to the base of 2. So you are 34.4674 to the base of 10 is converted to answer 1.2. Okay, so this is how it is done. Similarly, we'll see for octal. Same number we have taken. So again, the integer part, that is the integer fraction of decimal, is converted to base 8. Okay, so base 8. So here the integer part will be divided by 8 and the fractional part will be multiplied by 8. So for 34, the integer part is, so 34 to the base of 10, the divided by 8, we get 42. Okay, so it is 428, and 0.4674 is converted, that is, it is of base 10, which is converted to, what is the number from top to bottom? 35772. So it is 0.35772 of base 8. So combine the answer, your final answer will be of that, sorry, it is of 42.3572 of base 8. So this is how it is done for conversion of an integer fraction to binary and octal. So similarly, if it is going to be hexadecimal, integer part will be divided by 16 and the fractional part will be multiplied by 16. Okay, so you'll see an example, the same example I have taken. I have divided the integer part by 16. So the answer is 2 to 16 here, and here this is multiplied by 16. When I multiply the first fraction, it gets integer part 7. When the remainder fraction is multiplied by 16, again I get integer part as 7. The fraction is multiplied, it gets 10.470. So we don't have 10 symbols, so it will be converted into A. Then finally you will have 7. So the final answer will be of 22.77A7 of 16. So it is of 16. So next thing, we have already converted decimal to binary, octal and hexadecimal. Now we are going to see how binary, octal and hexadecimal are going to be converted into a decimal value. So here the basic step is simple. It is just converting face value into the base form into the power of position. Simple. So you have a face value into to which base and to the position. Okay, so for each base value you will add with this and you will get the decimal value. So that is how it is going to be done. So this is how you will calculate the decimal. So first thing, if it is a non-fractional part, the position value will be starting from left side to right side. If it is a fractional part, it will be starting from left side to right side. Simple. So non-fractional means from, just keep it in mind, if that is integer parts, the position value will be from left to right. Okay, so it is from left to right and it starts from 0. Okay, if it is a fractional part, okay, so the face value will start from right to left. It will start from right to left and its starting value will be -1. So keep that in mind. So let us see the conversion of first thing. So first, let us have the conversion. A binary number is converted into base 10. So this is an example of conversion of, okay, it's of binary to decimal. So this is an example of binary, that is from base 2 to base 10. Right. So as I said before, it is an integer number. Okay. So 1 0 sorry, we can have it as, so 1 0 0 1. So the position value has to be started from left side to, sorry, right side to left side. Okay, so it has to be calculated from right side to left side. You can see it starts from 0 1 2 3. Okay, so just multiply to the base is 2. So 1 into 2 power 3, 0 into 2 power 3. So if you are not comfortable with this mechanism, I can write like this. So 1 0 1 1. Okay, 1 1 0 1 into the base 2. Okay, into the base 2. So from the right side to left side, the power has to be increased. So it is 2 power 0 1 2 3. So what will be the answer? 1 into 1, which is equal to 1. This is 1 into 2, you will have 2. And this is 0 into 4, it will be 0. And this will be 1 into 8, which will be 8. So the answer is 11. Okay, so 1001 of base 2, the answer is 11 to the base of 10. Okay, so we can have another example. So this is how the integer is converted. So if you need, I can do another example. So let me have another example over here itself. So let me take 1100. Okay, so if it is going, so you can write like this. Okay, so it is 0 0 1 1. Now what is the base? Binary system, so you'll be having base as 2. Okay, then you write the position value. So 0 1 2 3. Now the answer is 0 0. It is 1 into 4, it will be 4. 1 into 8 8. The answer is 12. So for 11002, it is of 12. Okay, so simple. 8 plus 2 12. So this is the example for conversion of binary into decimal. So next we will see how fractional part is converted. So this is the fractional part. So same way you can have it. So if it is going to be 1101, so let me have it like this. So it is 0 point. Okay, so it's a fractional. So you write 111 into the base 2. It's a fractional part, so the base is 2. So fractional part, you have to start with -1. So -2, -3, -4. So which will be equal to 1 by 2. This will be 0. This will be 1 by 8. Sorry, it is 2 power 1, 2 power, I'm sorry. Okay, now this is a little bit wrong over here. So don't use this L. So if it is 0.1101, from bottom to top, it has to be like this. So into 2. So 2 power -1, 2 power -2, 2 power -3, 2 power -4. So this will be of 1 by 16. This will be 0. This will be 1 by 4. This will be 1 by 2. So totally it will be of 13 by 16, which will be equal to 0.8125 of base 10. Okay. So what only difference is, if it is integer part, the position value will be from top to bottom, it will increase in this method. Okay. So if it is a fractional part, from bottom to top, the position value will be increased. So -1, -2, -3, -4, we will increase it from bottom to top. So that's the example. Or if you are comfortable, so you can have a formula method. So if it is a fractional part, -1, -2, -3, -4, it starts from left to right, the power will be increasing. If it is a fractional part, from right to left, you have to consider. Now let us see how it is done for a decimal is converted into octal system. Sorry, that is a octal number is converted into decimal system. So here similarly 62. So here also you can use L division. 2 6. It's a fractional number. So to the base of 8 0 1. So it will be 2 here. 6 into 8, it is 48. So you will have 50. So your answer is 62 of 8 is converted into 50 of 10, right? So this is how it is done. So I will draw another example. So I'm going to convert 708 into a decimal number. So it is how converted. So the answer is 701 of 8 is converted into 456 of 10, right? So let us see how the fractional part is done in octal system. So 0.345 to the base of 8 has to be converted to the base of 10. Okay, so how do we do it? So 345, so I will write like 345. It's a fractional part. Okay, so 3 4 5. If it is fractional part, you have to start the position value from the bottom to top. So 8 minus 1 into 8 minus 2 into 8 minus 3. So this will be 5 divided by 512. This will be 4 divided by 64, and this will be 3 divided by 8. So the answer will be 0.447. So the answer is 345 of 8 is converted into the decimal value 0.447 of base 10. Right? So we have seen conversion of binary to decimal, octal to decimal. Now we will be seeing hexadecimal. So this is from base 16 to base 10 conversion. That is from hexadecimal to decimal. Same, we have taken 62 here. Okay, it's from C15. Okay, so we are going to take it as C15 over here. So what we'll do here is, so we'll convert the fractional part C15. Okay, so like same way we'll do it C15. Okay, so we'll take it as L division. So phi 1c, okay, into 16 power 0 into 16 power 1 into 16 power 2. So which will be phi into, okay, it's not 0, it's 1. And 1 into 16. And what is C value is? A is 10, B is 11, C is 12. So C will be of 12. So 12 into 16 to the power of 2, which is 256. So the final answer will be 3093. So the answer is C15 to the base of 16 is converted to decimal 3093 of decimal value. So if it is a fractional, you have to multiply. So AE1, okay, so we'll convert this into decimal value. So AE1, so into 16, and the powers will be from top bottom to top. So -1, -2, -3. So which will be 1 by 16 power 3, and this is E is 14. So A, B, C, D, E. E is 14, F is 15. So 14 by 16 power 2, and A is 10. So 10 by 16. So the answer will be 0.6798. So 0.AE1 of base 16 is converted into a decimal value of 6798 of base 10. So up to now we have seen what are the number systems, how the number systems are there, conversion of a decimal number into binary, a conversion of decimal number into octal, a conversion of decimal number into hexadecimal. Similarly, we have also seen conversion of binary, octal and hexadecimal to the decimal number system. So thank you. So the next session we will see how binary can be converted into an octal system. Thank you. We will see the rest of the number system in part B in the next video. Thank you.